Greetings, fellow scale modelers. During this last month, I've made a number of investigations as to how one is going to make this mold for the Canberra jet bomber project. And we need to understand, first of all, that this is an object about 700 millimeters long and 320 millimeters in diameter. It has been suggested to me that I should consider making the mold out of a polystyrene block and used formers and templates to measure my progress. Unfortunately, I do not want to work with polystyrene, even though it may be the cheapest and the easiest. It has also been suggested that one could use a CNC router to cut the polystyrene block, and I believe there are some people who are building a full-scale Spitfire using this method. I really am not keen to work with polystyrene because it is horrible to sand. It is also very difficult to cut, and you get a huge amount of mess. Also, the polystyrene, the white polystyrene, tends to become statically charged, and then you have a real problem of pieces of polystyrene sticking to oneself and in all sorts of other situations, all sorts of other places where you don't want it. It has also been suggested to me as an alternative to polystyrene that I could use polyurethane foam, and much the same applies here, in that I don't really want to end up cutting and sanding polyurethane, because whilst polyurethane does not make the same mess, I don't really fancy working in it in that format. So if I was to use a polystyrene block, then the polyester resins would not be compatible with it, and I would then need to have some sort of barrier to prevent the resins from which I intend to make the plug dissolving the polystyrene block. Now, polyurethane is not susceptible, does not dissolve using a polyester resin, and again it could be cut out on a CNC router. But I don't have a CNC router, and if I did, I would have to build a solids model and then use a 3D program to generate the G-code, which I'm not keen at all to do. Now, it is possible to get boards about 2 inches thick that one could profile, and then you could glue them together. Unfortunately, they don't actually match up terribly well with the overall circular diameter of the fuselage, which is 320 millimeters. I could also make the plug out of solid wood, and I don't want to use the little magongo I do have in the middle of the block, and I could jolly easily use a piece of ordinary pine and use the magongo on the outside and build up the mold or the plug in layers. However, the fuselage diameter is 320 millimeters, and my planar thicknesser only goes to 300 millimeters and will not take the 320 millimeters in one session. Not only that, but carving a circular fuselage nose section will be extremely wasteful of material and will create a great mess, neither of which I'm keen to do. I still think, and I'm still hoping, that my plank on frame method might generate the required plug, because it will enable me to minimize the use of materials, and then I can always fill the circular section later with polyurethane foam to strengthen the plug so that it won't be affected by making the relevant molds. I am also having a great difficulty in drawing the nose shape of the Canberra jet bomber, and I will continue that. This is a shot of one of my drawings that I'm trying to build this Canberra from. Now this model is the BI-8, which has the canopy in fighter style on top of the fuselage, which was common in later makes of Canberra, and I will just now show you a B Mark II, which is the bomber that I intend to build. But I thought I would show you this diagram because it's quite interesting. Firstly, it is quite clear that this is the pressure bulkhead at this funny angle, and that will in fact be an elliptical shape. But from the nose here at this point through to the pressure bulkhead, the nose section is definitely an ellipsoid, and all the cross sections through there are definitely circular. This here is the first transport joint, which is definitely circular, and one of the difficulties is that we don't quite know where the tangent point for this upper ellipse and the bottom ellipse begin and end. In a second I will switch over and show you one of the B Mark II drawings, but just for the moment please notice that you cannot really see what happens because of the nose wheel door blocking the view, and we do know from various sources that the top of the fuselage remains a constant circular section up to the transport joint. There is a section, obviously this piece here, which is ellipsoidal, which means that there's a section here which may or may not be truly circular, and it is difficult to tell. Not that it would make a great deal of difference, because once this aircraft is fully assembled, people will appreciate the aeroplane as a whole. It is unlikely that I would get any better drawings, because I have about 6 drawings at the moment, and I'm working from this one and my other smaller. This is one of my drawings showing the B-2 bomber version, and we can see where the pressure bulkhead is on this aeroplane. The cockpit is much further forward and suffered from a problem of not being able to accommodate a flat optical sight as in the interdictor Mark 8. Again, you can just see that the nose section is pointed downwards, and that angle is approximately 4 degrees. It is quite clear from this drawing that the top ellipse here actually has a tangent point at the forward transport joint. Yet from this drawing it is difficult to see, and I have tried to draw a line there. The nose wheel gets in the way of determining where this tangent point is. It does not appear on any of the drawings that I have to occur at the forward transport joint. Of course, if one is going to tilt the forward ellipsoid 4 degrees, one still has to remain tangent at this point here, and that then we can flip that up and mirror it about the 4 degree nose down angle, so that all of the section AA, for example, on this drawing does remain circular. There is, I believe, a small section between the forward transport joint and this section here that is actually not truly circular, and there are very few photographs which can indicate more good information. And having looked and examined the full-size original that I have access to on the ground, it is not entirely clear that that is any different from what I'm suggesting, that the top ellipsoidal section occurs back at the transport joint, the bottom one occurs at the bottom of the pressure bulkhead, which, as you can see, is quite a long way back. And obviously when they created the version Mark 8, they were very careful not to disturb the original layout of the construction, but just moved the canopy back. In the later Mark, I can't remember what it won, the one with a slightly larger wing chord, the navigator or the photo operator sat in the nose of the aeroplane, which was actually hinged. So this is the model I intend to build, and I want to do AB Mark II. Although I do not have the size of equipment to make this particular plug, it would be nice to make that equipment for later on. But I don't want this project to be stalled by the lack of equipment. I can get other people to possibly machine for me. That is assuming that I can make the relevant solids model. I have a number of problems in the nose section of the Canberra bomber because it has what appears to be a parallel section, but then an ellipsoidal section which is tilted down at an angle. The center fuselage section is slightly parabolic in the rear, and all we know for sure is that the two transport joints between the nose and the center fuselage, between the center fuselage and the rear fuselage, are definitely circular, and the nose section is circular. It is very difficult at this stage to determine which sections are not exactly circular, because the parts catalogue that I have shows various frames, but there are hatches at the top which cause the frame to be broken into various pieces. So to do a CNC routing exercise, I would have to first build a solids model. And the solids model I would generate would come out of FreeCAD, because that is a very nice package. I am not at all keen to use Fusion 360, even though it may be better, primarily because models are in the cloud and I don't want to be involved with anything cloud-based. Once I have succeeded in drawing the nose section on CAD, I can then move on to the actual design of the plug, and I hope to do that in the months that lie ahead. But in the meantime, I intend to make a sample of a couple of circular formers and see what kind of thickness of Magongo I will need to actually form the curves. It is not quite the same as planking a hull, because a hull has certain lines, and in the old days of the sailing warships, they used to line up the planks and they would taper the planks. I am not limited by that. All I need to do is to create a plug, and my goal is to create a plug with 3 or 4 millimeter or even 5 millimeter thick Magongo strip, and to then cover that with polyester resins, and hopefully that means a minimal amount of wastage. I intend to make the plug and coat it with a polyester resin after sanding and body filling the various places, so that I end up with a nice situation with a nice plug that is made out of Magongo. I will then coat the plug and continue to dry sand it with a polyester resin that is tinted with one color, and then once I'm happy with that, I will then move on to wet sanding in order to get a decent finish, and I will use a polyester resin with a different pigment, so that should I expose the pigment from the lower section, I can immediately stop wet sanding and replace and build up where and when necessary. The actual molds itself, or the molds themselves, will be made of epoxy and will be a total of 6 molds to build the fuselage as a whole. Remember that this model is about 3 meters long, and the actual molds themselves represent quite a significant amount of time in constructing them. It's time to bring this episode into land, and I will report back further next month.